In this video, we will analyze a set of data using correlation relationships and a line of best fit. You will need graph paper for this set of notes. So first, let's talk about what a scatter plot is. A scatter plot is a representation of a data set on the coordinate plane. So we have three scatter plots here. Notice it's really just points that are graphed. We can look at each scatter plot and try to look for patterns. We see this scatter plot is a little more spread out. This one has more of a decreasing pattern, and this one has more of an increasing pattern. Those patterns are called its correlation. It's a trend in the data, how the points in a scatter plot relate to one another as a whole. It's the pattern of the data. So looking at the pattern of the data here, this is really all spread out, and we really can't determine what kind of relationship these data points have. So we say that a scatter plot like this has no correlation. Our decreasing trend has a negative correlation because this looks like a line that has a negative slope. As we read the graph from left to right on this one, it's increasing from left to right. It looks kind of like a line that has a positive slope. So we would say this set of data has a positive correlation. We can also talk about how strong that correlation is with the value called the correlation coefficient. It's a value that shows how strong of a pattern the points in a scatter plot have. If it's exactly linear and it's in a positive correlation, we would say that's the maximum positive correlation they can have. They're exactly linear. So our R value would be exactly +1. If they're not exactly linear, but they're still going in a positive direction, we can say, well, maybe it has an R value of 0.8, and that means it has a strong positive relationship. If they're all spread out, we would say the R value is 0. They don't have a relationship. All those data points are not related to one another. If we have exactly a linear relationship, but in the negative direction, we would say that that has a maximum negative correlation. It's exactly negative, and it has an R value of -1. Looking at this next data set, we have a negative trend in the points. It's still kind of pointing negative, but notice that these points are a little more spread out than these points were. These are in what we call a tighter set of points. So notice that the R value here was 0.8. This one is 0.4. So a greater value in our R value means that it has a tighter correlation or a stronger correlation. Now this R value is negative because of that negative trend that we see. Now if we have a strong correlation and an outlier is just a point that's not really part of our data here, but it is outside of the normal trend. It does have a strong correlation, which gives it an R value of 0.7. That outlier kind of pushes that R value to not be exactly linear. Now, we say that a set of data has a strong correlation if the R value is greater than 0.5. So notice this one here was greater than 0.5. But if they're more spread out, it'll be less than half, so less than 0.5. And that's kind of what this value was here, or less than -0.5. So less than -0.5 would be like -0.6, -0.7, -0.8. That shows a stronger negative correlation. So you can either have a strong positive or a strong negative, or you can have a weak positive or weak negative. We would say this is moderate. It's really close to 0.5, but you could have ones that are a little weaker. All right, next, if we have a set of data that we see a linear pattern in, we can find the line of best fit. And we actually practiced this in our last lesson. We used our calculator to find the line in between our tables of data. And we're going to do the same process for these scatter plots. We're going to open a new document, select our option for adding a list in a spreadsheet, label our columns, fill in our X and Y, and then menu 413 is how we find our linear regression, our line of best fit. Okay. We will practice this more when we get to class next.